welcome to another module in this massive open online course. So, we are looking at generation of a narrow band frequency modulated signal. We have said that a narrow band frequency modulated signal is one in which the modulation index beta is very small, significantly smaller than 1. Let us now look at how to generate a wide band FM signal, that is using the indirect method. Correct. So, first we generate the narrow band frequency modulated signal, and then we convert it into a wide band FM signal by a frequency multiplier. So, I can use frequency multiplication to generate a wide band FM signal. So, what we can do to generate a wide band frequency modulated signal, I can use frequency multiplication. Okay. So, frequency multiplication, this can be used to generate, this can be used to generate a wide band signal. Okay. So, what do we mean by frequency? So, we pass our narrow band FM signal through a frequency multiplier. Okay. So, let us say this is a frequency multiplier. And the output is S tilde t. So, this multiplies the frequency by a factor of n. So, we input our narrow band. So, this is let us say a narrow band FM signal. This is our narrow band FM signal, and this is our output is a wide band FM signal, and this arises because let us say the input of the FM signal, that is your narrow band modulated signal ST, has let us say an instantaneous frequency given by FIT. So, this has let us say input frequency FIT or instantaneous frequency, that is given as FC plus KF AM cosine 2 pi FMT. This is my input frequency, this is the input frequency, correct, frequency, or let us say frequency of the input narrow band FM signal, or this is your instantaneous frequency of input narrow band FM. Then the output frequency you can see is FOT. The output frequency will be, since we are multiplying the frequency, this will simply be n times FIT, which is equal to n times FC plus n times KF AM times cosine 2 pi FMT. This is the output frequency, and now you can see the carrier frequency of the output signal. The carrier frequency of this output signal, the signal that is the output of the frequency multiplier, is n times FC. So, the carrier frequency, resulting carrier frequency equals n times FC, and further you can see the frequency deviation. Now, let us look at the frequency deviation. Okay. So, carrier frequency is n times FC, delta f, that is frequency deviation, is max your FOT minus n times FC, which is equal to max n times KF AM cosine 2 pi FMT, and this is equal to n times KF AM. So, delta f the maximum frequency deviation. Okay. So, this is basically your maximum frequency deviation or peak frequency deviation. The maximum frequency deviation, and therefore, beta or beta output is this n times kf am divided by fm, which is equal to n times beta, which is n times kf am divided by fm. This is your beta, all right. So, basically what is happening using this frequency modulation, using this frequency multiplication is that your the input is a narrow band frequency modulated signal, the output is the signal with frequency, that is the frequency of the instantaneous frequency of this narrow band frequency modulated signal multiplied by n. Therefore, the resulting carrier frequency is multiplied by n times fc, alright. So, carrier frequency becomes n times fc, and also the peak frequency deviation, which was previously kf times am, is now n times kf am, and the peak frequency deviation is increasing. Therefore, the peak frequency deviation to the frequency of the message, that is fm, becomes n times kf am divided by fm, which gives us a modulation index beta output of n times beta, alright. So, we are able to increase the modulation index, alright, achieve a multiplication of n in the modulation index by using appropriate frequency multiplication. So, that basically gives us, so this basically enables us to increase the or enables one to increase the beta for wideband FM. So, frequency modulation helps us increase the beta, and therefore, we will see later when we will talk about the bandwidth of frequency modulated signal, as the beta increases, then the bandwidth occupied by the frequency modulated signal increases. That implies that the frequency modulated narrow band, as the bandwidth increases, it progressively becomes a wideband frequency modulated signal. Okay. Now, let us look at one of the techniques to achieve frequency modulation. One of the techniques to achieve frequency modulation is to use of a nonlinear device. So, frequency modulation can be achieved, frequency multiplication, your frequency multiplication this can be achieved through passing through, this can be achieved by passing S3 to a nonlinear device. This can be achieved by passing the narrow band signal, your ST, narrow band frequency modulated signal ST, through a non-linear device. That is the key, that is considering a non-linear. Obviously, linear device cannot be used for frequency multiplication, because for linear time invariant system, you can see that a sinusoidal signal is input with a certain frequency, then the frequency of the output sinusoidal signal will also be the same frequency, alright. So, a linear time invariant signal cannot be used for frequency multiplication. However, a non-linear device can be used for the same purpose, and we are going to illustrate that. Okay. So, consider, so that is the key, we would like to use a non-linear device for frequency multiplication. For example, okay. For example, consider the following nonlinear device. Consider the following nonlinear device where our input is ST. This is your nonlinear device which performs a cube law operation. So, the output is a s cube of t. So, input, this is your input and this is your output, which is a times s cube t, and you can clearly see this is a cubing operation. So, this is a non-linear device, all right. It is straightforward to see that this is a non-linear operation. So, this is straightforward to see this device is a non-linear device. Okay. This device is a non-linear device. Okay. So, let us say the input signal to this is your narrowband FM signal, that is ST equals your AC cosine 2 by FCT plus beta sine 2 pi FMT, that is the input to this. Let us call this as, this is basically denoting this by theta IT. I can say this is AC cosine theta IT, this is my ST. So, the output signal equals, so when ST is the input, the output, let us call that as S tilde T, that is equal to A times AC, A times S cube T, which is AC cosine theta of T whole cube, which is basically, now we will use a property of cosine cube of theta. Cosine cube of theta, we will use a trigonometric property for cosine cube of theta. Cosine cube of theta is cosine theta or cosine 3 theta, rather cosine 3 theta plus 3 cosine theta divided by 4. So, this is the property of cosine cube theta that one can use. So, cosine cube theta is cosine 3 theta plus 3 cosine theta divided by 4. I am going to use this property to simplify the output. So, the output is A AC cube cosine cube theta IT, which is A AC cube times cosine cube theta IT, I can write as cosine 3 theta IT plus 3 cosine theta IT divided by 4, where here I have used this property cosine cube theta equals cosine 3 theta plus 3 cosine theta divided by 4 to simplify it. Now, let us substitute this expression for theta t here, and therefore, you can see substituting expression substituting the expression for theta IT, we have this will be A times AC cube, well cosine 3 theta IT, I have to write the long expression. So, AC cube divided by 4 cosine 3 theta IT, that is cosine 3 well into 2 pi FCT. So, that gives me cosine of 6 pi FCT plus 3 beta sine 2 pi FMT plus, well 3 AAC cube divided by 4 cosine theta IT, that is again cosine 2 pi FCT plus beta sine 2 pi beta sine 2 pi FMT. So, this is the next expression for the output of the non-linear device, output signal of the net signal for the output of the non-linear device. And now, if you can look at this component, this is at frequency Fc and this component is at frequency 3Fc or NFC. So, this is achieving a frequency multiplication by a factor of 3. You can see this is basically frequency multiplication by factor of 3. So, this is achieving frequency multiplication by a factor of 3. So, I can retain this component, filter the other component at frequency Fc, alright. So, if I have a filter that is centered at 3 Fc with an appropriate bandwidth, I can filter out, I can block the other component at frequency Fc. As a result, I will get the component. So, pass this through filter. So, pass through filter centered at 3 Fc and block, and therefore block component signal component at Fc, and therefore the output, net output will be AAC cube divided by 4 cosine 6 pi FCT plus 3 beta sine 2 pi FMT. Okay. So, basically now we have achieved frequency multiplication by a factor of. So, this has basically achieved frequency multiplication by a factor of. So, this has achieved frequency multiplication by a factor of, this has achieved frequency multiplication by a factor of 3. Therefore, the net beta, that is output beta output equals 3 times beta. Okay. So, the output beta, so the modulation index beta output is the, this is the output modulation index or modulation index of the output signal. Modulation index of the modulation index of output signal is 3 times beta, where beta is the modulation index of the input signal. Similarly, we can consider other non-linear devices which are of the form raised to the, which are the form signal raised to the power of n, and that results in a frequency component, output frequency component at n Fc. Okay. So, if we consider to multiply it by a factor of n, in general I can consider a non-linear device which is A raised to the power of n, and therefore output will be A Sn to the power of t. This will contain frequency component at n Fc. As we have seen, raised to the power of 3 contains frequency component 3 Fc. In general, signal raised to the power of n will contain frequency component at n Fc. Now, filter this using filter centered at n Fc. Using or band pass filter filter this using filtered centered at NFC, and that will result in a frequency modulated signal, results in a frequency modulated signal, gives your frequency modulated signal at carrier frequency equals naturally n beta, a carrier frequency equals NFC, and modulation index equals n beta. Modulation index equals n times beta. So, that is the importance. So, that is how we generate a wideband frequency modulated signal using the indirect method. First, basically, as we have seen in the previous module, first we pass the signal, we modulate, we use an approximation of the narrowband frequency modulated signal using the property of low beta, correct. We generate, and that is, we use an indirect method to generate the narrowband frequency modulated signal, all right, using an approximation. Now, once we have generated the narrowband frequency modulated signal, I can scale, I can increase, make it a wideband frequency modulated signal through frequency multiplication. That is, if I pass it through a frequency multiplier, then the carrier frequency, the instantaneous frequency is multiplied by a factor of n, therefore, carrier frequency is multiplied by a factor of n. The beta modulation index of the input signal, frequency modulated signal, is also multiplied by a factor of n. And one way to achieve frequency modulation is by passing the signal through a non-linear device. The non-linear device, for instance, which raises the signal to the power of n, right, results in a component at n times Fc, okay. Now, filtering this at n times Fc, now filtering this with a filtered centered at n Fc yields the FM signal with center frequency, carrier frequency NFC and modulation index n times beta, alright. So, this is the indirect method for generation of a frequency modulated signal. We will stop here. Thank you.